This video is on measures of variability, which is a broad category of descriptive statistics. And we are really going to focus on how different scores are or how different responses are for a variable in a data set. We just talked about central tendency in the previous video, and that was really focused on this idea of what's the center of the data set, what's common, whereas variability is more about how much those responses vary or how much those scores vary. So picture that I give an exam for this class, and there's 30 students in it. And I have another class with 30 students, same class, and they both get the same mean. They both have a mean or an average exam score of 70. If I just report the central tendency, in this case, the mean, that's really not going to tell me a lot of information about how much those scores are spread out. And I might make the mistake of thinking that those classes did similarly on the exam. However, let's say that one of the classes has a mean of 70, but everybody got a 70. And so there's no variability. I would look at that and I would say, whoa, that's weird. What's going on here? And then if the other class had scores ranging from 50 to 100 with a mean of 70, that tells me something different. I would also want to, visualize it and look at what the scores look like, but that variability adds to your understanding of what's happening in a data set. So the first way that you can describe variability is with with range. And so range is used, it can be used for ordinal variables. For example, if we were talking about like your class ranking, and I asked you to tell me if you're a freshman, a sophomore, a junior, a senior, and I collect all the data from whatever class I'm collecting data from, and I find out that they range from, that my sample ranges from freshmen to seniors. That's a range for ordinal variables. I just have categories that have a natural order to them. It's not super helpful. Like, okay, do I have one senior? Do I have mostly seniors? Do I have a couple seniors? I mean, that doesn't really give me a lot of information, but it does give some context. Like I know what kind of the range of values is. Same thing for interval or ratio variables. If I, have a number, I could say scores range from 50 to 100. That tells me something about that exam, or if scores don't range at all. And for interval or ratio variables, you can actually calculate the range by doing the minimum from the maximum. But again, it's not super informative. It just gives you a little bit of context for what you're dealing with. Now let's talk about standard deviation. I'm skipping over variance, sorry, I said that weird, because you don't really report it as often. I mean, you do maybe in more complicated, when you get more advanced with statistics, you might report it, but at your level in class, you're not typically going to report the variance. You will report standard deviation. So if you have an interval or ratio variable, you would report standard deviation with your mean. You can kind of picture the mean and standard deviation holding hands, they go together. You're not going to report it for ordinal variables because they are just ordered categories that are assigned a number for analysis purposes, but the number is not really meaningful. Different from Likert type scales when you have multiple that you're adding together. We've talked about it before, we'll talk about it again. But you will use this for total scores or for other interval or ratio variables. This is really common, and the way that it works is that you get the difference between your scores and the mean. So let's say that your data set is exam scores. You would go through and find the difference between each score, which is X, and the mean, and those are called deviations. Then you would next square each of those deviations. So if there was a 70, and that's a bad example. Let's say there was a 90 on the exam score and the mean was 70, then the deviation is 20, and I would square that. And I would get all the deviations squared, and then I would add them together. And that's this top portion here. Then you subtract it by n minus 1, so the sample size minus 1. The minus 1 is just a correction for it being a sample, and so there's a little more variability there. You divide your sum of your deviations that are squared here by this n minus 1. And then that part that I just talked through is your variance. So that inside part is variance or S squared. And that's just the basically squared deviations from the mean, average deviations from the mean, but squared. And so again, it's not something you report as often because you're talking about a squared distance. And so unless the analysis calls for reporting that information, it just doesn't, it's not really useful. We do often get the square root of that, and that is the standard deviation. So it's the average distance between each score and the mean approximately, not exactly. I do have a separate video that's specifically on that if you want more of a conceptual, a longer conceptual explanation of that. And last, we have the interquartile range. So the IQR or the interquartile range, I don't feel like psychology people use IQR as much. I see it a lot more with sociology. But this is a box plot, and you can see I have social loafing as this variable here. And so along this y-axis are my social loafing scores. And then you can see that we have these different points on this. So between this and this is 100% of your data. If there were outliers, if there were weird extreme scores, they would be little dots on the end. This is from Jamovi. And then this is broken into 4 quartiles. So here's the first quartile, second, third, and fourth. I described those backwards. So 1, 2, 3, 4. These are our quartiles. We're just cutting it up into quarters. So 25% of our participants would fall into each of these quartiles. Now, this is the median. So that's the 50th percentile. So 50% of responses fall below that line. And then 25 per the 25th to 50th. So you have 25% of your scores that fall there, 25% fall there. And so that includes in total 50% in this box. So the range containing the middle 50% of scores. And the 50% is just the number of people that fall into that range. I'm not talking about actual scores or anything with the 50%. I'm talking about the number of people that fall into that range of scores. And so we can see that this part right here, this is 50% of the responses. And so you can kind of see like, oh, that's the middle 50% of people. It's a little bit less spread out. And so if you have outliers or if you have a big difference here than you do here, you might use the IQR instead. So that's another way that you can talk about your variability is you can talk about the interquartile range or the range containing the middle 50% of your scores. So that's it for variability. Most frequently, you're going to report standard deviation for your interval and ratio variables. You might find it helpful to report range, but those are really the main ones that we'll be dealing with for this class.